Alright, welcome back. Now we're going to be looking at the average rate. So the average rate is basically just how much it changes, or a quantity changes per unit of another quantity. So just like with that last one we did in the previous video, we determined the average rate and we're just simplifying it down. Now we have to find out what the rate is and how to find it. So let's get started with our first one, which is question 3. Now, for question 3, we're just going to be looking at a culture of 3,600 cells that increased to 5,400 cells in 3 hours. So in order to find out what the average rate is, all we have to do is find the total change over the total change in another quantity. So we have here 5,400 cells, and to find out the quantity of change that's occurred this time, we're just going to take away our initial quantity of 3,600 cells, and we're going to divide it by the change in time. And the change of time is just going to be 3 hours. Alright, so it would be 3 minus when we started, which would be 0, so it would just end up with being 3. Right, so we just do that quick calculation. So 5,400 minus 3,600 is going to be 1,800 cells in 3 hours. Now we've got our rate. All we have to do is simplify, and to do that simplification, just perform the division that's here. So we can rewrite this just like we did with the last video. 1,800 cells in 3 hours is the change, okay? And we want to divide by this final quantity. So if we divide 3 by 3, we just get 1 hour. And if we divide 1,800 by 3, we get 600 cells. 600 cells in 1 hour is the same as 600 cells per hour. So for every hour we leave this culture, we would expect the number of cells to grow on average by 600 cells. Let's look at question 4. So a water tank had 615 liters at 8 AM and 459 liters at 2 PM, and we're going to find the rate, or find the average rate of change for every single hour. So let's get started. Now, it's important to recognize what's happening. Unlike the previous one, where we have an increasing rate of change, we're growing more cells. In this question, we're going negative. So our rate of change will be a negative number because we're losing water over time. So let's start out with exactly the same way of doing it. It's just one quick change. Because it's going to be negative, we're going to put the smaller number at the front, and then all we have to do is calculate what the time difference is going to be. So from 8 AM to 2 PM, that'll be 6 hours. Alright, do that quick calculation. So this is minus 41 to get to there, and minus 115, so that will be equal to negative 156. If you want to know why I'm doing that, I'm just finding easier numbers to work out the basic arithmetic first. So if I take away 41 first, then what I'm really doing is I'm moving towards an easier number, and then after that I'll move to essentially the equivalent of 500, and then after that I can just take away the additional 115. Alright, now that I've done that, I have my rate. It's 156, or minus 156 liters in 6 hours. Okay, and if I divide both sides by 6, well, I'll get 1 hour here. And 156 divided by 6 is just 26. So this will be negative 26 liters. Alright, in 1 hour, or minus 26 L per hour. Now, one thing that I will stress that I haven't done here is you should really write these a little bit with a larger space between the value and the unit. Okay, and the reason we leave this value is to make sure no one confuses that unit for an additional number. It's very easy for a leader to become a 1 and for you to mistakenly write down the wrong solution. Alright, that's it for this video. Hopefully it's helpful, and I will see you in the next one.